Okay, hi everyone. My name is Shrestha. I'm part of HackIllinois staff. Um, yeah,
Hi everyone, I'm Ayush. I'm also part of HackIllinois staff.
yeah. Thank you all so much for joining us for the web dev workshop. Alice and Rem will be leading this workshop, and they'll be talking a little bit about backend web dev and databases, which will be super useful for a lot of you as you work on your projects this weekend.
Thanks for the intro.
If you haven't done so already, please install the HackIllinois mobile app so that you can redeem points for attending this workshop. We will send the code sometime during the middle of the workshop. Now off to Alice and Rem.
All right, awesome. Hello, everyone. I'm Alice. I actually graduated last semester, but I was a CS major at UIUC.
Hey everyone, I'm Rem. I'm a sophomore studying computer science, so I'm just here to help out with the workshop.
All right, awesome. I will share my screen. Oh, wait. Okay, can everyone see this? All right, awesome. So yeah, today we'll be going over a brief introduction to backends and databases, which is a very important part of web apps. All right, so an overview of what we're going to go over today. So first, we're going to provide a little bit of context for the backend and database by talking about web dev as a whole. And then we'll move on to backend topics specifically, and then databases. And then we have a short little demo where we have like a live coding follow along of a context directory with a basic front end. All right, web dev overview. So yeah, very basic high level. This is what the web looks like. So this is the,
Sorry to interrupt. I think we can't actually see the PowerPoint, so you might have to reshare your screen.
Sad, okay. Okay. Oh wait, can you not see it now?
Still can't see it.
No.
Okay, amazing start. Okay. Okay, I guess I can just share this tab. Can you see this?
Still can't see it.
No. Yeah, it's just your desktop. I think maybe try like unsharing and then resharing.
Yeah. Can you see this?
Looks like a black screen.
Okay, hold on. Maybe does someone else want to try sharing?
Okay, let me try sharing it.
Okay.
Does this work?
Yes, beautiful.
Okay, I'll let me load this next slide. Okay.
All right. Okay, I'm already on like, yeah, talked about the table of contents. Yeah, here we go. So, all right, resume. So this is at a very high level, the entire web stack. So you have your front end, which is what the users see and which is what lets people interact with your web app. And then the back end is the sort of liaison between the front end and the database. And then the database is just where you store your data. Next, okay. Oh, no, go back.
Sure.
Okay, so this is, I drew this nice little diagram so you can see how each one interacts with each other. So as you can see, because the backend is a liaison between the front end and the database, the front end never actually manipulates the database directly. So basically, I'll talk about this using an example. So let's say you're searching up a friend on Facebook. So on the front end side, you would like type into like a search bar, right? So the front end gets your input, it passes it to the back end saying like, hey, return all the results of like people whose name matches what you inputted. And the back end actually goes, it processes that request, and then it tells the database like, hey, give me the correct data for all the users that match. The database returns it to the backend, and the backend, it might do is like a little bit more processing to make it show properly on the front end, and then it passes it to the front end, and then the front end finally displays a list of all the people whose name matches what you inputted. Yeah, and then you might be wondering like, why can't a front end actually interface directly with a database? So there's three main reasons. The first reason is there's like major security issues with that, because you're giving users direct access to your data, basically, and that might contain like very sensitive data. The second reason is for performance issues. So modifying the database, actually, it takes a long time relative to like everything else that is going on in a website. So that is pretty detrimental to the user experience if the front end is just directly manipulating the database. And then also number three, for simplicity's sake, so limiting the functionality of each part of the stack makes it easier to develop like everything together. Next slide. All right, another beautiful drawing. Okay, so today, as you can probably tell from the title, we're just focusing mainly on the interaction between the backend and the database, although we'll put everything into context like with the front end as well. Next slide. Oh, yeah. So now we're onto the backend section. So before we talk about the backend specifically, there's a few important concepts that you need to know before. So HTTP, this is the foundation of the World Wide Web. So it's a protocol that allows the transfer of data between clients and servers. And client is another name for front end, while server is another name for backend. Yeah, so here's the four main HTTP methods. The first one you see here is post, which creates a new resource in the database. Or it doesn't touch the database yet. This is mainly focusing on like the front end requesting the back end to modify the database, if that makes sense. So a post request would request for a new resource to be created. A get would retrieve a resource from the database. And then update, so put and patch basically do the same thing, but yeah, updates an existing resource in a database, and then deletes a resource. So yeah, it's pretty intuitive. Okay, and then another important topic when we're talking about backends is what is an API? I feel like a lot of people have this question, and sometimes myself, I'm like, yeah, I actually don't really know what it is every time someone asks me, but to clarify, an API stands for Application Programming Interface. So this refers to a set of methods that allow for communication between two pieces of software. So this is like a very intentionally like vague description, because it really could refer to any sort of communication. Like mainly when we talk about APIs, we refer to the like front end communicating with the back end, or the API would be the back end providing a set of methods so that the front end can like interface with the back end. And then also we could be talking to like an external API. So this lets whatever app you're creating interface with, like Spotify, for example, is a pretty popular API that people use in like hackathons and stuff like that to retrieve data from this external source. And then, but it could also refer to like the backend interfacing with the database. Like the database technically provides like a set of methods as well to manipulate it from the backend side. And it could even be with like software to hardware, right? So the software could communicate with like an LED light bulb, for example, to tell it to light up or something. So yeah, it can refer to a lot of different things. And then I also linked some nice API docs, in my opinion. I think the Stripe one is probably the best that I've ever seen. Rem, if you want to click on it, I don't know if you shared your whole desktop or not. Oh, amazing. Okay. Yeah, so whenever you want to use an external API, they usually provide you with some reference that will help you know like what all the methods do and like what methods there are even. So yeah, Stripe, if you haven't heard of Stripe, it's like this payment system. So companies can use it to like, or if you can see under core resources, it says like balance. So you can like check your balance on Stripe and stuff like that. Oh, someone said Discord API is pretty cool too. Yeah, I haven't seen it before, but you can probably check that out. And yeah, you can see like on the side, it provides some more information about different, I guess I'll get to this a little bit later, but you see like the URL, it provides you a URL, and then it provides you like some more context, like what you can pass into that URL to be able to access some information. I think you can see it better if you press like the balance tab on the left side, if you see under core resources, and like scroll down a little bit. Oh yeah, so it provides you with what the object you are trying to access looks like in like JSON format. So that's pretty helpful. And if you scroll down a little bit more, yeah, here. So yeah, basically tells you like where you can access this resource, like what URL to use, and then what the response looks like. Yeah, there's also dark mode, which I think makes the doc so much better. Okay, you can go back to the slides now.
Okay. Whoops, sorry. Sorry, the Zoom thing is blocking me. Okay, got it.
Every time. Okay. Oh, one more. Oh, sorry, I
Yep.
forgot to say one thing. Yeah, so one last thing, you can use Postman to test your endpoints. Oh, I didn't explain what endpoints are. Well, we'll talk about that later too. But yeah, basically if you're writing your own API, you can use Postman to test like to like send requests without using a front end. You can send requests to your backend, and then you can see like what the response is. And yeah, it's a pretty useful piece of software. I highly recommend downloading it if you need to write APIs and stuff. Okay, so let's revisit the definition of backend. So it's a liaison between the front end and the database. So there's 3 points I want to emphasize here. So the server listens for requests from the front end, for the client/front end, which is usually triggered by some user action. So if you think back to the example that I gave, like if you're searching for a friend on Facebook, that user action would be typing an input into the search box. And then basically once the server accepts a request, or it like once the server gets a request from the front end, it processes that data, and then it queries the database accordingly. And query just means like gets information from the database or modifies the database in some way. And then lastly, the server returns the data to the front end, which displays it in a user-friendly format. Yeah, next slide. Yeah, here's some examples of pretty popular backend frameworks. So you have Express.js, which is a JavaScript framework, and then Flask and Django are both Python, and Spring Boot is Java. Yeah, today we will be talking about Express.js specifically. Oh, yeah, so Express.js is a Node.js backend framework, and Node.js basically just lets you run JavaScript outside of a browser. So you can write both front ends and back ends in JavaScript, which makes it pretty powerful. Okay, so now let's talk a little bit about routing and endpoints. So you heard me mention endpoint a little bit before. This refers to a URL that defines where you can access a resource. So as you can see in this very short example, the endpoint would be /members. So this endpoint basically lets you get information from, or get member information from the database. And then, yeah, the full endpoint would be localhost 5000 /members. As you can see in the comments, it says, or the last line says app.listen 5000. So this basically means your server will be running at localhost 5000 on your local machine. So then if you want to access it from a browser or from Postman, then you would go to localhost 5000 backslash whatever endpoint you defined. Yeah, okay. And then a route refers to kind of this like whole function, this whole app.get function. So it defines how the server responds when the client hits the endpoint. And actually, it doesn't even have to be like a front end. It could be like anything that hits this server's endpoint at /members. So here you can see, oh, I think I talked about the next slide. Yeah, okay. So a route takes, in Express, a route takes two parameters. The first one is an endpoint, which we talked about, which is in the format of a string. And then the second parameter is a callback function, which takes in a request object and a response object. So this lets you access information from the request and then also attach information to send back to the client in the response. So if you can see like that function parentheses rec comma res, that's what I'm referring to when I talk about a callback function. So this function will basically be triggered anytime the user hits /members, or sorry, not user, anytime this /members endpoint is hit from the front end or from something else. Okay, so this is, oh, the emojis got messed up. Okay, well, this is what is returned when you navigate to localhost 5000 /members in the browser. So yeah, it just says hello world because that's what we told to do. So that's pretty cool. All right, so now let's take it up one level. So now let's add in the database so we can actually do like some more useful things. So can you go to the next slide? So you might have noticed the first thing that we added were these two keywords. So I'll first talk about await, because then it makes more sense to talk about async afterwards, I think. So await basically blocks execution of subsequent code until the function call it's in front of returns. And then async denotes that a function contains an await. So async is basically just saying like, oh, this function, like this callback function, right? Because the async is in front of the callback function. This contains an await somewhere inside of it. That's just like a very basic explanation. Like async await and asynchronous programming in general is like a pretty complex topic, but I don't want to get too much into it. But yeah, one thing to note is that async and await always come in pairs. And sorry, give me 1 second. Okay, so you might be wondering like why async and await are necessary, and like, I guess like what does it really mean? So any network call, and by network call, I mean like a database query mainly, or this could be like using an external API or something, or never mind. Yeah, usually just a database query because external APIs are accessed from the front end. But yeah, any network call / database query takes a really long time compared to other function calls. So since the server needs to continuously respond to requests from the front end, if it has to wait for each database call to return data before doing anything else, like it won't be able to accept other incoming requests that happen like after this database call has been initiated. So that's kind of like if, let's say you're cooking in the kitchen and you're just like waiting for some vegetables to cook and you're just not doing anything else, right? Like in the meantime, you could probably, I don't know, prepare some other food, like cut up some meat or like fruit or something, like which would save you some time. And like the meat and fruit don't have to rely on the vegetables being cooked because it's like a separate thing. So that's basically what async and await kind of let the server do, is be able to handle other requests while it's waiting for the database to return data. Yeah, hopefully that made a little bit of sense. And next slide. Okay, so, and then you might have noticed that we have this member.find function. So yes, the long-awaited database call. So this is what actually returns all the member objects in the database. And we'll talk more about this later. Yeah, this is MongoDB for reference. Yeah, next slide. And then at the very end, you see the res.send all org members, which we defined was what returns from that member database call. So yeah, this is how we finally return the data from our database to our client. And one thing to note is that data passed between the client and the server is usually in the form of JSON, which stands for JavaScript Object Notation. Okay, so now when you navigate to localhost 5000 /members, you can see that it actually returns an array of database objects. Yeah, so did something useful. Okay, now we'll finally talk about databases. Oh wait, actually, before that, does anyone have any questions about anything I just talked about? Feel free to post in the chat or unmute yourself. Or wait, I don't know if you can unmute yourself, but use the chat. All right, cool. I think we can move on. Okay, so what is a database? So we just said it's a place where you store your data, but it's like a little more complicated than that. So a database is actually an organized collection of structured information. And there's something called a database management system, which controls the data that you have. And then, so yeah, it's an interface between the users or programs and the database. So this is what actually allows you to read and modify the data itself. And when we talk about database, we're referring to both the data and the database management system together. Next slide. Yeah, so here's some lovely common databases. So as you can see, there's two SQL ones. There's like PostgreSQL and MySQL. And then Oracle is also a SQL-based database. And then the rest of them are all NoSQL, which we will also talk about later. And oh yeah, next slide. Yeah, today we will be focusing on MongoDB. All right, so first of all, SQL versus NoSQL. This is a question I feel like a lot of people usually have, or like you get asked this in an interview maybe, but yeah, so at a high level, SQL refers to a relational database management system. So this basically means it's like table-based. So the data is structured in like as a table, and then the rows are, each row in the table is a database entry, and then each column in the table is like a property of each entry. So if you can kind of think of it as like an Excel spreadsheet, like kind of that sort of format. And a really important thing is that in order to like aggregate information about like one entry in the database, you might need to join multiple tables together to get like the entire information for an entry. Yeah, and then if you're looking at this illustration here, you can see like the entries sort of look like tables that are like connected to each other, right? And then you can ignore that cube thing. I think it's just like a multi-dimensional table. And then for NoSQL, you have like, is structured differently than SQL databases. So you can have like key value databases, graph databases, document-based databases, column-based, and yeah, I'll explain the difference a little bit more in the upcoming slides. Okay, so here's an example of a query. So as I said before, a query is just like a way for you to like retrieve information or modify information in the database. So you can see a SQL query is on the left side, and then on the right side is the corresponding MongoDB query. So let's break it down a little bit. On the left side, you have these select, from, and where statements, right? So select, or you can see like user ID, comma, status. So select basically takes the attributes that you want to look at from the database or from the table. And then from just specifies like what table you want to select these attributes from. And then where is sort of like a filter. So this will return all the user ID and statuses of entries that where the status is equal to A. And then, yeah, on the right side, same exact thing. You can see like db.people refers to the database that you want to, or sorry, not the database, or the table you want to focus on. I think MongoDB calls it collection, so the terminology is a little bit different, but, and then you see this find function. So this is also sort of like a filter function. So the first like the thing in braces, that's your filter. So you specify that you want the status to be A. And then the second set of braces, you can see this is what's called a projection. So you can see it will only return, or you're kind of selecting what attributes you want to return. So you want to return the user ID and the status, but not the underscore ID. And in MongoDB, each object in the database has an auto-generated underscore ID field, which is unique. So that's what that's referring to in this example. And yeah, you can see in MongoDB, you pass in everything as like JSON or like JavaScript objects. So it's really nice to use this along with Express because they're both sort of JavaScript based. Next slide. Yeah, okay, so some more differences. So SQL is relational, NoSQL non-relational. We already talked about that. And table-based and not table-based. So yeah, basically NoSQL is just, everything is not compared to SQL. But yeah, one thing to note is that SQL actually has its own query language, and SQL stands for structured query language, I'm pretty sure. But in NoSQL, there's no like sort of standard declarative query language. It's different for each case. So I guess it's more diverse in this aspect. And then there's something called like vertically scalable and horizontally scalable, which is not that important to know at this stage, but basically it means if you want to increase your processing power for SQL, you can like increase the power of each machine that you have. Whereas in MongoDB, you can add more machines, which will also increase the processing power. Yeah, and then some examples of SQL databases are, well, I mentioned this before, like the SQLs and Oracle, and then yeah, oh, and then like to give specific examples of each type of NoSQL database. So MongoDB is a document-based database. Redis, which I think Facebook uses, is key value pairs. A graph database is Neo4j. And then column-based database is Apache Cassandra. And next slide. Okay, so you might be wondering like, oh, what should I use then, like in different cases? So honestly, there's no definite rule for when to choose one over the other, but you really want to pay attention to what kind of data you have and what you want to do with it, because picking the more suitable option will make your queries faster and your life easier. And then here's some more criteria, I guess, that might help you decide which one you want to use. So SQL has a predefined schema. It's like very rigid. You can't really easily change it. And oh yeah, schema means like basically like you're defining what properties your database object has. So yeah, in SQL, like schema is hard to modify. Whereas NoSQL, it's like more flexible / dynamic. And then SQL generally, I guess you can do some more complex queries, or it can handle more complex queries. And then NoSQL, yeah, I just put an X, but really it's like these changes are very, very like minute. And they only really show when you have like when you're running like a huge application or something. Like for small scale applications, like it won't really make a difference performance wise. But yeah, NoSQL is also better with hierarchical data, especially MongoDB, because in MongoDB, since the data is structured as objects, you can have like nested objects. So you can have like a property that is an object, and then you can define like all the fields inside of that, which is something that you can't do in SQL. In SQL, you would have to make another table and then like join like multiple tables together to be able to get all the properties of that object. And then lastly, SQL, again, take this with a grain of salt. Like it can handle a higher transaction volume, whereas NoSQL is like less so. All right, and let's get more into MongoDB. So MongoDB, to reiterate, is a NoSQL database that stores entries as JSON-like documents. All right, so yeah, and by JSON-like, I mean BSON, which is very, very similar. I actually forgot what the B stands for, but it's just like MongoDB's specific version of JSON. Yeah, and like I said, you can store nested objects. You can also store arrays in each object, as you can see on the left side. Yeah, I use a avatar reference. So here, this object has an underscore ID field, which is auto-generated, and a name field, email, birthday, and a hobbies array. And you can store all of that together collectively in this one database object. All right, and yeah, as I said before, it's more dynamic and flexible than SQL and works well with the JavaScript stack. And yeah, the unique underscore ID field is mainly used for querying like specific objects in the database. Next slide. Okay, so MongoDB Atlas is MongoDB's cloud database, and I think it's very, very useful and intuitive to use. So yeah, you can store, view, and edit your data in their cloud service. Like they handle everything for you. There's also a free tier, and there's a very easy to use web interface. So as you can see on the left side, you have like 2 database objects displayed, and then one of them is being edited directly through the website, which is nice because in other databases, you might have to access it like through the terminal and like do some querying to be able to directly modify your database, which is not as easy to do. All right, and now let's talk about querying in MongoDB. Oh yeah, I'm seeing like a lot of messages saying the app is broken. We can probably fix that during the demo maybe, or it lags. Okay, anyways, yeah, so revisit the HTTP slide. So as you can see, there's like the very first column of this table, you have like these 4 actions: create, read, update, delete. And these actually correspond directly to database operations. Next slide. Yeah, they're actually called CRUD operations. Like that's an actual saying. Yeah, so if you look at the example on the right side, we have a couple of queries. We have a .find query, which is the read, corresponds to a read operation in the database, and then the .insert1 query, which corresponds to a create operation. All right, so as I mentioned before, these query functions take in JSON as parameters. And here are some useful update operators. We don't have an example of the update here, but we will in the demo. Yeah, so actually, before I talk about that, I'll talk a little bit more about this code snippet. So we have a database object at the very top, this top Fang's object. And then when we do db.collection.find and we pass in an object containing that object's underscore ID field, then it returns the same object that is displayed above. So if you had multiple objects in the database, it would only return the one that matches the underscore ID. And then an example insert. So we define a new object directly inside of the insert one function. So we define a Saka object, which has the exact same structure / schema as the TOF object. And then what this does is it will just add this new object to the database. So the next time you query the database, if you're like retrieving all the objects in the database, you can just pass in an empty object to find, and it won't filter out anything. It'll return all the objects at once. Then it will return the new object that you created, like it will return TOF and Saka. All right. Oh yeah, sorry. The update operators. So there's a few. So there's the, as you can see, there's like $signs in front of it, and MongoDB. That's how MongoDB denotes like operators. So set adds new fields to a document. Push adds new values to an array, and then pull removes values from an array. Yeah, it's a little bit hard to see without a specific example, but MongoDB's documentation is really good. I linked it like directly in the slides, so if you want to take a look at that on your own time, we'll be sharing the slides out afterwards. All right, next slide. Okay, and then Mongoose, I think this is the last slide. Yeah, so Mongoose is an object data modeling library for MongoDB and Node.js. So basically what that means is it's kind of like a bridge between if you use SQL and you want like predefined schemas, or you want to be able to define schemas on your objects in MongoDB. This is a way for you to do that. Like Mongo lets you create schemas and also has like schema validation. So what that means is that if you're trying to create a new object in the database and it doesn't match the schema that you defined, it will throw errors. And then it also has a few special query functions, which are a little bit easier to use than MongoDB's native ones. So one example of this is .save, which inserts a new document into the database if the document is new, but if it's not new, then it just updates it with what you passed in. And the snippet on the left is an example of creating a schema, in this case for a person, which corresponds directly to the TOF and Saka objects that we created. So this is the schema that we defined for them. As you can see, each field has a type, so you can specify types. You can specify if it's required or not. If like you try to create a new object and you don't have a required field, it will also throw an error. And then you can specify that it needs to be unique. You can also specify a default value if nothing is passed in for that attribute. All right, next slide. Okay, yeah, I know that was a lot to digest. So please, if you have any questions, drop them in the chat right now. I linked a few resources here too for Express.js and how to set up an Atlas database. Yeah, I see a lot of your questions are related to the demo, related to the demo, not related to the slides. Anyone have any questions about the slides or any of the concepts? Okay. Okay, it's a long question. Sorry, I need to read it. Okay, wait, I'm gonna read it out loud. So, okay, you're using Node.js for a project and you want to know whether you can remember clients who refresh a page as the same using headers, cookies, or the Express session module, or whether you have to have a database like MongoDB to remember a client if they refresh the page. Okay, yeah, well, that's a very complicated question. So there is something called a package called Express session and like cookie session. So I'm pretty sure you need to use it with a database, or else there's no way for the server to kind of remember who was logged in or not, because it like stores, kind of like stores these sessions in the database, if that makes sense. So it will persist across like, if you refresh a page on the front end, it will still be in the database. Does that make sense? All right, hopefully that made sense. Okay, cool. Any other questions? Yes, nice. All right, well, if there's no other questions, we can go on to the demo, and hopefully we can get it done within 15 minutes. Sorry, Rem.
Oh, sorry, I was muted. Did I stop sharing?
Yeah.
Okay, was there a problem with the demo? Wait, do we release the link or something?
I honestly don't know.
Let's see.
Oh, this is the HackIllinois code. Okay, but also people are saying the app is broken.
For
Oh,
the
wait.
one?
Oh, okay, wait,
yeah.
this is our sorry, go ahead.
Yeah, they were talking about the app. That's like something that staff is dealing with.
The actual demo, right?
I don't think it's with the demo. It's with the code that we sent for the workshop. Yeah.
Okay, because
It won't
the
affect you
code,
guys.
yeah, the code on GitHub contains like my login info for the DB. So if everybody uses it, it's going to be using the same account. So that might be a problem.
Wait, I don't think that should be a problem.
Okay.
Yeah, I don't think it should be a problem.
Okay, so anyways, okay, let's get started then. If there's no problem with that. So it's not with the code then.
Yeah, it was confusing because everyone's like, this code isn't working, like this app is broken. I'm like, oh no, like our app is
Wait,
broken.
so what were they running?
No, it was like you like put in a code for attending like this workshop.
Oh, okay.
Yeah.
Okay, got it. Okay. Oh, okay. So okay, that makes a lot of sense. All right. Can you see the screen?
Yes.
Alrighty. So here's what we're going to be making today. Excuse the poor front end. It's very bad. Basically, it's a contacts database. And here's a really rough, we won't be coding the front end. This is just so we could see what's going on. You'll be able to add like new contacts to a database, something like this, and it would show up. And when you refresh the page, it would still be there. You could also update. So you could change my name to John or something and update the name. You can also delete this record. So that's basically what we'll be coding. So before we do all of this, you first have to create a MongoDB, like a database. And as Alice mentioned, you use this MongoDB Atlas thing. So we won't be covering that. But basically, yeah, you'll have this database, this MongoDB database, and we're going to be writing the backend API to manipulate this database. Okay, so first thing, we'll just start from a blank project. So let me stop this server first. Okay, so we'll just be starting from scratch. So the first thing you could do is just make a folder for your project. We'll call this like demo. Okay. Okay, and to just create a bare bones version of the project, we'll do npm init -y. So if you just do npm init, there's a questionnaire, sort of, that's kind of annoying. So we could bypass that with the -y. It would just create a bare bones version of a package.json. So if you haven't used npm before, package.json specifies the dependencies you'll need. So basically what libraries you'll need to install. to run this program. Okay, we'll use Visual Studio Code just to code this up. Okay, so first thing, we're going to be using Express, so we need to install that. So npm install Express. We'll also be using Mongoose to communicate with the MongoDB database. So we'll install these two packages. So we'll just wait a small while, and then dependencies should show up in the package.json. So yeah, here they are. Okay, they're installed. And to run a program, usually you like to just type something like npm start. So let's specify what npm start means by putting that here in scripts. So we don't need to test. Maybe you want to write tests, but we don't need that for now. So start. And if you type npm start, so here's the command start.
I think someone requested to slow down a little bit.
Oh, okay, slow down. Okay. Okay, let me speak a little slower. Sorry about that. So the actual command we'll be running is nodemon index.js. So index.js will be the entry point to our program. Let me just make that right now. And actually, let's put that in a folder called src. So that would be the source code. I'll make a new file here called index.js. So this will sort of be, the entry point for our program. So here, let's do nodemon src/index.js instead. If you don't have nodemon installed, you might need to install this first. So you would do something like npm install -g, which is to install it globally, nodemon, I think, something like this. Basically, nodemon is a tool that allows us to monitor how a server is running. So that would give us a little more info on how the server is doing. Do I need to stop right now, or should I just keep going, or should I wait for people to install this?
I think someone asked, like, what are you doing and why are you doing it?
Okay, so oh yeah, sorry about that if I didn't clarify. So what I'm trying to do is I'm going to make a API to communicate with the database. So if you recall Alice's slides here, if you look at this part, so we'll be making the backend part. It would just be an API, and it would we would be writing these. Let's see, we would be writing these routes and endpoints to specify how a user or a client might interact with the database. So we'll be writing this part of the stack. Is that clear, or? Okay, and this is definitely going to go over time, so probably by about 10 minutes or so.
Yeah. Okay, so what file are you using, or what file are you going into? I guess maybe explain like the package.json a little bit more, and then the index.js.
So package.json, this specifies sort of the main info for our whole project. So you can specify like author field here. The more important one is dependencies. This will specify what libraries you need to install. So by default, when I did npm install express mongoose, that means my project will require these two libraries that someone else wrote. So we'll just install these. And then when you need to run these, then npm knows, okay, we have to install these two packages first if someone else wants to run your project. And for scripts, this specifies shortcuts. So we could also just type something like nodemon index.js here, but that potentially is pretty long. It might get really long if you have more complex commands. So we can just specify a shortcut called start. That way, when we do something like npm start, it's equivalent to running this command. And main specifies the entry point for our program. So that's index.js. Actually, that should be src index.js, I believe. So yeah, that's that. Does that make sense? Actually, no, it should be index.js. Okay, I'm just double checking the code I wrote. So yeah, so this should be the correct sort of thing. Yeah, and you don't need these. We can delete these. Okay, can I continue, or?
Yeah, I think it'll probably start to make a little bit more sense once you.
Yeah, it'll start making a little more sense as we just start. So yeah, So we'll just make a very basic server first. First thing we'll do is import the Express library. So to do this, we use require Express. This will import Express, and then we can refer to it as Express here. And then if we make an instance of the Express app, then this would be the server we're running. And then to just listen, we do something like app.listen. So you don't have to code this, we'll change this later, but just to demonstrate what would happen if you just do something simple like this. Let's do console.log server running. Yep. Put the semicolons. So if you run this now, you should see something called server running. So what this is doing is, if you recall Alice's slides here, app.listen, it opens a server that listens on localhost port 5000. Okay, so npm start here. Yeah, so now we just see server running. Now, we haven't coded anything yet. We haven't coded any of the roots or the endpoints. So currently the server does nothing. But yeah, we have a bare bones Express server up running now. Okay, we'll control C this. Yeah, so in order to have actual meaningful interactions, we'll need to connect to the MongoDB database first. So to do this, we'll use the mongoose library. So we'll import that also. Const mongoose equals require mongoose. Okay. And then so we can delete this part. In order to connect to the database, we use the mongoose.connect. Oops, I'm not sure what this is. We use the mongoose.connect function. We'll need to specify the URI. So when you create the MongoDB database and you use the MongoDB Atlas, you can get the URI from I think database access. So you click database access here, add new database user, and then or it might be network access. It's not network access. I forgot I could get the URI. Alice, do you remember where do you click to get the? It might be
connect. Yeah.
Okay. Yeah.
Connect your application.
Yeah. So you click connect here and then connect your application. Then okay, we're using node.js. Okay, so here's the sort of the URI that we'll be using to connect to the MongoDB database. So I'm going to copy and paste this string, put this here. Now I have to replace these angle brackets with an actual username and password. So you can specify those here in the database access part. So I already have that. Let me just copy that from my reference code. So let's see.
Oh, also, one thing to note is that you should never actually paste.
Yeah, don't actually do this.
Like, or if you want to, like, if you're actually storing stuff in your database, like for us, it doesn't matter because it's just a demo, right? But if you like push this to GitHub and everyone can see your Mongoose or MongoDB connection and your username and password, that's a no-no, right? I think GitHub actually warns you of this if you do that.
Yeah, it does.
Yeah, the way you get around that is you have like a .env file where you can which is like only a local file. Like you should not push that to GitHub either. And then you can store it in that file and then like load it dynamically from the server. But yeah, we're not going to do that here. This is just for demonstration purposes.
Yeah, so don't actually do this. Like theoretically, you all could just log into my database now and change it. So yeah, that's very dangerous. But okay, we'll specify some options here. So this is use new URL parser. I think this might be the default on new versions of Mongoose. So basically they have various parsers to parse this URL, and we'll just specify we'll use the new one and use unified topology. So you don't have to really care that much about what these mean. Basically, these are just options that specify how to parse this. Okay, so after we connect, this is a asynchronous function. So we only want to make sure that the code we specify below only runs after we actually connected the database. So we'll specify the code within a .then block, and So what this means is we will only run this .then block after we connect. So think about it as connect, and then we'll do the rest of this code. And then we'll make a Express app. And then let's do the app.listen thing again. So let's just to see if the server is good.
Oh, also another thing, this is the same as what I was talking about in the slides, like the async await. The .then syntax basically just means it will wait for the mongoose to connect to the database, and then it will execute the rest of the code. So it kind of blocks execution of the second part until the first one returns.
Yeah, so it's pretty much the same thing as the async await. And then I also add a catch block here. So this is always a good practice. In case something here, fails, like, oh, you failed to create the server or something like that, we can catch an error and print it to the console. So pretty much you always add this at the end. In fact, Node will warn you if you don't add this catch block. Okay, so let's see if this works now. So this will work. So if this works, if we see the server running, it means we've successfully connected to the database. Else we won't be in this block. Okay, npm start. So hopefully it's okay. Okay, so server running, so it means we've connected to the database. Okay, so next thing we'll do is, so for this app, we'll be looking at how to store contacts. So Mongoose provides a really nice way to make, they call it a schema. So you can think of it as an object. If you think of it like a Java object, basically we'll specify, how a contact should look. So I'll make a new folder and call this models and make a file inside called contact.js. So, when you're doing your HackIllinois project, you potentially might have a lot of models. So you might want to put it inside a folder. And so to specify the schema, we just import mongoose first, require mongoose. Okay, and then const schema equals mongoose.schema. So you can name this anything, but I'm just gonna name it schema. So let's make an instance of the mongoose schema. And for contacts, let's just specify two things. We have a name, name of the person we want to contact, which will be a string, and a phone number. This would be a number. You can also specify, you can look at the documentation. There are a lot of different types you could specify here. If you want to specify an array, maybe something like titles, then you can do something like this. I'll give you an array of, potentially their titles. To keep it simple for this demo, though, we'll just use these two. Okay, so now we have the schema. We need to export it so other files could access it. So module.exports equals mongoose.model. So this will compile a mongoose model based on the schema we provided. So this is pretty much standard for pretty much any schema you could create. So it'll pretty much look the same except for these internal fields we provide. Okay, so now we have you can think of it as a contact object. To use it inside our index.js, we need to import it. So I will, okay. So actually we'll be using another file called roots.js to do the, what's it called? Interaction with the database. So we won't import it here. So to do that, let me make a new file called roots.js. So this file would be all the endpoints, all the roots. So basically this stuff, it will specify at which URL I could go to and for which HTTP request I can send, like get or post, to interact with the database. So I'll put all of those functions inside this roots.js file. Okay, give me 1 sec. Let me double check I have everything correct here. Okie doke. Okay, so I'm gonna just copy and paste these imports real quick. And then we're gonna put the roots.js file inside this file later in a bit. So we'll code this part first. Make an instance of a router from express.router. And then down here, we could specify those routes. So one potential one, let's say you want to get all our contacts, router.get, and then we could specify the endpoint. So in this case, I'm going to do something like contacts. This makes sense. We want to get all the contacts, and then async rec res. So this is the callback function Alex was mentioning. Rec is the HTTP request that has been sent by the client. So this will contain info that's sent by the client. And this is the HTTP response we want to send back in response. So this would be the stuff the client gets back after accessing this endpoint. So for example, const contacts equals await contact dot find. Now I need to import contacts here. Const. Let me double check the const contact equals require, and it's in the folder models. So /models. Dot means the current directory, so it's in the current directory, and then it's in the models directory, and then contact. So we don't put the .js at the end, just the name of the file without the .js. And so this will return us all the contacts we could find. And then in response, we send back to the client all these contacts. So we retrieve these, and then we now send it back to the client. So this will complete the GET request for all the contacts. One thing we need to do is module.exports. We also need exports so other files could use it. So module.exports router equals router. Yep. And now once we have this, we could use it within index.js. So we will import it, const routes equals require /routes. So again, we don't put the the .js at the end. And where am I? Then const app source. Okay, yeah. And to specify that we'll be using, the roots in this file, we just need to call app.use. And then here's the URL that will be preceding it. So right now, here's the endpoint. So it starts with HTTP and then localhost port 5000. That's what we're specifying here, 5000. And then whatever you put here will be whatever comes next. So it makes sense to just call it something like API. So it'll be an API for clients to access our contacts. So then it'll look like this, /API roots. So all the roots inside this file would be added. So in this case, for a GET request, it would be /contacts. So our whole endpoint would look like localhost 5000 API /contacts. And if we access this endpoint now, that would give us all the contacts we have inside this MongoDB database, hopefully. Okay. So let's see if this works. Now we don't have a front end yet to sort of display our results. So that's one alternative is to use Postman, like what Alice was mentioning. That will allow you a nice interface. Another one we could use is a command line tool called curl. So let me run the server first. So npm start. Hopefully we have no errors. Okay, so the server is running. I'll open a new window, so keep the server running. And then another one we could use is the command line tool called curl. This will allow us to make an HTTP request. So we'll make a request to HTTP localhost port 5000 API /contacts. Okay, it gives us an empty list, which is sort of strange since I think there should be stuff inside our database. Collections. Okay, yeah, it does look like we have, so I'm supposed to get a list of these, but they're not showing up for the moment. Okay, let me double check everything. So, okay, this is correct. Contact.find. So I'm not too sure why it's giving me an empty. Let's continue and let's make the root for adding a contact first. So then maybe we could try to remedy that.
Oh, I think it's because you didn't create the API folder. Just do /contacts. Is it? Oh, wait. Right? Or does it not matter?
Wait, so where's the error?
Or like you specify like /API /contacts, but there's no API directory.
You mean this one?
Yeah.
I think that just appends to the URL.
Oh, really? Okay.
Yeah. So that specifies like what comes before the roots. Let's just do the post request first, so then we could post and then see what's up after that, I guess.
Oh, is this called my first database? No, it's called database. It's just capital database, capital D. In the
good catch. Yeah, so this is the problem. Oh, very good catch. Oh, wow.
That
yeah,
was
so
someone else.
Oh, okay. Thank you, chat. So yeah, our database is called database, but I called it my first database here, so that's bad. Thank you. Yep. Okay, so this should hopefully work now, maybe. Oh, did I close the server? Connection refused. Oh no, failed to connect. Oh, okay, great. Whew. Okay, so yeah, we have the so we did get back the response. That's great. So it's not going to look great. That's why we need a front end to display the results nicely. But in the command line, you can see this stuff is working. So return stuff in JSON format. So it's an array of objects. And you can see, okay, we have an object. Name is Alice, phone is 111. And this is the unique ID that's associated with each object. This is auto-generated by MongoDB. Okay, so we can see we have Alice and Bob, which is correct. We have these two things. So now let's make another endpoint so we can add to this database. Okay, so again, we'll go back to roots.js. This will be where we'll be handling all the roots and the endpoints. So this gets all contacts. And we want something to add a contact. So router dot, and this will be a post request now because we're adding to the database. We'll use the same endpoint /contacts, but just with a different HTTP request, which is the post request. Okay, async rec res. Okay. Oh, and one thing I forgot to mention, it's good practice to wrap these things in the try catch block, because this might fail. You know, if you fail to find these contacts, basically your program will crash. You don't have these try catch blocks. So you could add something called try catch. And then if anything here fails, then you can send a status 404, which means, okay, something bad happened, and then send back an object, something like error get request resulted in error. So this will allow you to troubleshoot a little more easily, or else you would have pretty much no info as to what went wrong. Okay, add this. Okay. I guess to simplify the rest of the code, I won't be writing these try catch blocks, but when you debug, that might be helpful. I'll just be writing the code itself. Okay, so const contact equals await contact dot find one. And let's see, underscore ID rec dot gram size. So I'm going to explain what this means in a moment.
Okay, I think you need the ID in the endpoint, unless you're going to do that afterwards.
I need the ID in the endpoint. Thank you. Yeah. Yep. I need the ID. Oh, I need the I.
Oh wait, no. Wait.
Oh, yeah, I'm looking at the. Sorry, I'm looking at the wrong reference right now. So this is the code for getting a specific contact. So if you want to get a specific contact, each contact has an ID associated with it. So you'd have an endpoint, something like contacts ID, and this would give you the contact corresponding to that specific ID. So this is what this code is doing here. Sorry if that confused you.
You also need to change the post back to a get.
Back to a get. Yep. Thanks. So this will find one contact that has the corresponding ID as to what we passed in here. And once we get that, we can send it back to the client, and that's all our code. So let's try getting Alice. So this is Alice's ID. So I'm going to copy this. So now if we try to access this endpoint with the ID, it should give me Alice. Okay, so that's great. So this will allow me to get a specific contact. This might be helpful if you're getting, if you're managing a profile or something and you want a profile for a specific person. Okay, now we'll be getting to the creating a new contact.
Sorry, real quick.
Yeah.
If you don't want to use your terminal and you don't have Postman, you can actually put this localhost URL into the browser, and it will also return like the objects on the browser page.
Ooh, that's a good point. Oh, that's a good point. So something like just local host 5,000 API contacts. Oh yeah, that's nice. Ooh, it actually looks nicer.
Oh, wait, what do you have? Wait.
Firefox.
Nice. Okay, Firefox, the best.
Okay, so this might be the better option then, I guess. Okay, cool. Okay. Oh yeah, and okay, so back to where we were, creating a new contact. Okay, this will be a post request to contacts. This will be our endpoint. Okay, so these pretty much all look the same at the top. So to post a contact, we'll need to make actually a new contact. So we'll do that first. Const contact equals new contact. Oops.
So I think there's you put a period instead of a comma after rec.
I put a period. Oh, okay.
Yeah.
Wow, I'm making a lot of errors. Apologies.
No, it's fine. This happens every live coding session,
Yep. Okay, and okay, so we want to post stuff corresponding to the schema. So look at the schema. We have name and phone, so we want to specify those. So name, we will have rec.body.name. So when the user actually does the HTTP request, they will have to specify some kind of body, which specifies, okay, what kind of name I want. So in that body, we'll expect a name field. That's what we'll be getting here. And then phone, rec.body.phone. Okay, so this will be our new contact object. And to save this to MongoDB, the syntax in Mongoose is just contact.save. We will await contact.save because we want to block until this contact has been saved. And then after that contact has been saved, we'll send it back to the client. Right. So this should do. So without the front end, how to do this with curl is a little more complicated. So we will do curl. Sorry, let me go back. Okay. It will be curl this, and then to specify the request. So by default, it's get. We want to use a post instead. So -x is the command line argument to do this. Post. Now this is specific to curl. If you have Postman, you can just use that nice graphics interface. And then we want to specify the content type. We'll be sending in a JSON object. So content type application /JSON. And afterwards, I'll be just showing the front end code to show you how you could do this with a React front end. But for now, we'll use the command line. -D will specify our actual body. So our actual body would be a string, and inside we'll specify the things we want in JSON format. So first thing, we want a name. This could be, say, let's see, Olivia, maybe. Wrap it in strings. And then phone. Phone's a number, so we don't need to wrap that in a string. This could be, anything. Think this should do. Okay, so it doesn't look like it's succeeding. Let's see, -x post title name Olivia phone. me see if there's any errors in the server that are being logged. Okay, so some errors here. Cannot read property name of undefined. Okay, I had something. I had a problem like this yesterday. Shoot, what was the solution here? Yeah, so this is another good reason to put a try catch block. If you don't, then it's going to be, sort of messy like this. Cannot read name of undefined. Okay, might be a problem with the post request, content type application JSON. So I don't recall what the problem is. I guess what we could do is just keep going for now. So let's see what else. I'm still wondering why that's the problem. Name string. Okay, I guess we'll continue for now. It doesn't look like it's the problem with the roots, so continue for now. Okay, so we have our GET request for displaying all the contacts, a POST request for creating a new contact. For API, you probably want to supply two more, one for updating and one for deleting. So for update, there are two options. You could use a put request or a patch request. So what a put request does is it overwrites your old object with a completely new one. We're going to make a patch request. So what a patch request allows you to do is it allows you to partially update your existing object. So it keeps your existing object, but it updates specific fields within the object. So we'll be updating that, update existing contact. So to do that, we do router.patch. The endpoint will contain an ID because we are only patching a specific contact. Okay. Again, we'll use the same code for finding the corresponding contact. And then note that the patch request can specify only certain fields. So for example, we have name and phone, but the patch request might only specify the name. So in that case, we want to change the name, but keep the phone number. So the code here does that, if rec.body.name. So if the patch request contained a field called name, then we will update it, contact.name equals rec.body.name. And if it has a phone number, we will also update that. Okay. And then once we have that, then we have the updated contact, then we can save it. So await contact.save. So save, if it doesn't exist, creates a new one. If it exists, it will update. So this is very convenient. And then we will send it back. So as you can see, all this code is pretty short. So using Mongoose and Express allows you to have very, very short code and pretty straightforward code for creating an API, backend API to interact with the database. So the last one we'll be making is a delete. Now, I'm going to be testing everything afterwards, trying to figure out why this doesn't work later. Okay, delete contact. So this will be a delete request. Again, we'll be deleting a specific contact. So we need to get that first. So the syntax here is contact.delete one. There's directly a method called delete one. That would delete the object whose ID corresponds to the ID specified in the HTTP request. Okay. And then once that succeeds, so this blocks until we have successfully deleted the object, then we will send a status 204, which specifies we deleted it, and then send it. Okay, and in this case, for these types of ID matching endpoints, you probably do want to write the try catch block, just because, you know, if the user specify a non-existing ID, then you want to be able to catch that. So we can do something like this. Again, res.status 404 signals an error, and then res.send could be error ID does not exist. So probably we're going to jump to this block if the ID does not exist. So we won't be able to delete this object because it doesn't exist. So it will display this instead. Okay, and that's actually all for the backend. So these are all the routes we'll need, and also the endpoints. And going back to the okay, so I know why the post request didn't work now. It's because Express doesn't know what format to expect the objects to come in first. So before doing this app.listen, so before, you know, starting the server, you have to specify app.use express.json. Yeah, so I forgot this yesterday as I was coding the demo as well. So you need to do this first so that Express knows to expect the JSON object. Yeah, so once you do that, I expect the post request to work now. Okay, great. Yeah, okay. So this post request now, so now we have an extra Olivia in the database, and this just returns the posted object. So if you go look at our database now, we should have an extra entry. Yeah, okay, so we now have Olivia. So that's also in our database now. Okay, cool. So I won't be going over the curl commands for the update and the delete. You can search those up yourself. It'll be pretty similar to, you know, this format. I'll just show you the front end. This is probably what you guys will be using when coding this along. Oh, so first of all, is there any questions before I just show the front end code and how you could interact with the backend this way? Okay, if there are no questions, one extra thing that's very important is you need to enable something called CORS. This stands for, so I'm Googling this right now. This stands for cross-origin resource sharing. So to be honest with you, I'm not too sure what this means, but if you try running a local host server like what you're doing right now, and then you try accessing an endpoint at this local host server, your browser will give you some warning saying some cross-origin request denied or something like that. So in order to bypass that, so you could have your front end interact with your local server, you need to specify app.use CORS. And then in order to use CORS, you also need to import it. So const CORS equals require CORS. And this reminds me that I forgot to install CORS. So let's npm install CORS real quick. And this will allow us to use CORS. Okay, so this is now installed. Okay, so this should be all the code for the backend. Now I'll just jump to the code that I already wrote for the demo. So we can just, because the point of this workshop is not the front end. But here's a potential way you could structure your project. So the thing we just wrote is the API. It specifies the endpoints we'll be using to interact with the database. Now to display it, we need a front end that interacts with our backend API. So I have this other folder called client. Now I used a React front end for this. You could use any front end you want, but a React front end is pretty nice because it's also in JavaScript, so it communicates nicely with the Express backend. So yeah, so this is what you see here in this React app. Oh, I closed it. Let me cd client npm start. Let me start this real quick. Okay. Okay, I think I might have stopped the server. Yeah, okay. I need to start the server now. Oh, whoops. cd API. It's already in use. Okay, so it should be already running. Okay, yeah, I don't know why that did not display. Yeah, okay, so now we have this Olivia. So I'll sort of just quickly explain the components going on here. The render here is the actual code displaying the display. Now, this is probably the worst front-end code you'll ever see. Please don't do this, like inlining the CSS. Please make a separate CSS file. Yeah, I apologize for this poor front-end code. But what I'm doing here is, for instance, to get all these contacts, I'm using this function I wrote called get contacts. So what it's doing is it's using fetch, which is a really handy function to deal with HTTP requests. So for any HTTP request, and you can use the fetch function. In this case, it's a get request, so we don't need to specify anything additional. If it's something else, you might need to specify it, like if you do a post request, you say method post. But for this, it's just a what's it called, a get request. So this URL will correspond to the URL we wrote here in the client, if you remember, in the API, if you remember. So this would be this contacts endpoint here. Yeah, so in React, we will use the fetch function, or it doesn't have to be in React. This is a JavaScript function. It was the fetch to contact this endpoint. Then, so after it returns a response, so after we return a response, so after this contact is sent back to us, we'll be turning it first into a JSON object, and then I'll be calling this setState function, which you can imagine this as sort of a private variable. If you code in Java, basically it's updating this instance variable to this response. And now I'm displaying that here via where is this code? Oh, via this, yeah. So I'm basically looping over all the contacts, and for each contact, this is the display. So this is a list element, and then so that's what you see here. And this form stuff is for updating and deleting. That's what you see here. So yeah, for the API I just coded, you could send an HTTP request to those endpoints via the fetch function in JavaScript. Now I know there's another function to do this. I kind of forgot the name, but fetch is the one I usually use. It's really easy to use. You can see it sort of looks similar to what we were doing with curl, but in JavaScript syntax, we'll be using a post. It's going to be a JSON content, and then for the body, you want to send over these name and the phone. So yeah, I don't want to go into too much detail because it might take forever to explain this. But yeah, this is a quick overview for using a front end to connect to the backend. Okay, is there any questions or any other thing you would want to be explained? I can't see the chat.
Oh, I wanted to say, I think you're referring to Axios, which is similar to Fetch.
Oh yeah. That's right. Yeah. 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 Alice is a lot more familiar with this stuff than I am. So definitely take her advice.
You did a great job, Rem.
Okay, I can't see the chat for some reason. Oh, okay, I can see it now. Okay.
I think I tried to answer all the questions in the Zoom or in the chat.
Oh, okay, thank you.
Yeah.
Yeah, but if you guys just want this front end code as a template, actually, you probably shouldn't. This is really bad front end code. You should probably write your own front end code. Sorry. Okay, if that's if there are no other questions, okay, I guess we're good then, are we? Or
I think so.
okay, I
Yeah.
can paste the. Should I paste the link to the repo or something?
Oh yeah, I posted in the chat, and
Oh,
then
okay, cool.
they're gonna share it on Discord.
Yeah, we'll share to the Discord.
Okay, if you want me to post the repo on like a HackIllinois GitHub, I could also do that because yeah.
Sure. Yeah, we can figure that out after
Okay.
the workshop. Yeah, thanks everyone for joining us today, and huge shout out to both Alice and Rem for presenting. Yeah, stay tuned for more events later tonight, and also if the code isn't working for you in the app for like the workshop code, then make sure to fill out the Google form so that you can still redeem your points for attending today. Yeah, thanks everyone for joining us.
And also be on the lookout for later tonight. We'll be releasing a web dev challenge. So check out the Discord for that. Thank you so much, guys.
All right. Okay, bye-bye.
Wait, Hisu is in here. Hisu.